Have you ever looked up at an airplane and wondered how something so heavy can soar through the air? The answer lies in the delicate balance of four fundamental forces: lift, drag, thrust, and weight. Lift is the upward force that counteracts gravity. It's generated by the wings as they slice through the air. Drag is the opposite of lift. It's the resistance an airplane experiences from the air it moves through. Thrust is the force that propels the airplane forward. Think of it as the engine's push. Lastly, weight is the force of gravity acting on the airplane and everything inside it. For an airplane to fly, these forces must be in perfect harmony. Lift needs to be greater than or equal to weight to keep the plane from falling back to the ground. At the same time, thrust must be greater than or equal to drag to keep the plane moving forward. It's a delicate dance of forces, but when it all comes together, flight becomes a breathtaking spectacle. The heart of any airplane is its engine, the powerhouse that generates thrust. Over the years, we've developed several types of airplane engines, each with unique characteristics and applications. Let's explore three major players: turbofan, turboprop, and turbojet engines. Turbofan engines are the most common type found on commercial airliners. They're incredibly efficient for high-speed, long-distance flights. You can recognize them by their large, fan-like blades at the front. Think of the Boeing 747 or the Airbus A380, both powered by powerful turbofan engines. Next, we have turboprop engines, which are commonly found on smaller aircraft. These engines use a propeller to generate thrust, much like their older piston-powered cousins. They're perfect for shorter routes and can operate from shorter runways. The ATR-72, a popular regional airliner, is a prime example of a turboprop-powered aircraft. Finally, we have turbojet engines, the grandfathers of modern jet engines. These engines are simpler in design compared to turbofans, relying primarily on jet propulsion for thrust. While not as fuel-efficient as turbofans, they pack a punch when it comes to speed. The legendary Concorde supersonic jet, capable of crossing the Atlantic in under 3 hours, was powered by turbojet engines. Now let's delve into the heart of a jet engine, specifically the turbofan, to understand how it transforms air into thrust. The process is a symphony of physics and engineering, but I'll break it down into digestible parts. Imagine a giant fan at the front of the engine. As this fan spins, it sucks in massive amounts of air. This air is then compressed and directed into combustion chambers, where it mixes with fuel and ignites. This combustion creates hot, expanding gases that are forced out of the back of the engine through a nozzle. As these gases blast out, they create a powerful thrust that propels the airplane forward. You see, it's all about Newton's third law of motion. For every action, there's an equal and opposite reaction. The force of the hot gases exiting the engine creates an equal and opposite force that pushes the airplane forward. But that's not all. Remember that giant fan at the front? It's not just there for show. It also bypasses some of the air around the combustion chamber and out the back of the engine. This bypass air provides additional thrust and helps to make the engine much quieter and more fuel efficient. As we gaze towards the future of flight, we're on the cusp of a new era powered by electric and hybrid electric propulsion systems. These technologies hold the potential to revolutionize air travel as we know it. Imagine a world with quieter, cleaner, and more efficient airplanes soaring through the skies with a fraction of the environmental impact. Electric airplanes powered by batteries are already taking flight, albeit on a smaller scale. These pioneers offer a glimpse into a future where short-haul flights could be powered entirely by electricity. Hybrid electric propulsion systems, combining the power of batteries and traditional engines, offer even greater potential for long-distance travel. However, challenges remain. Batteries still lag behind jet fuel in terms of energy density, meaning they can't yet store as much energy for their weight. This limitation affects the range and payload capacity of electric aircraft. But don't be discouraged, for innovation is a relentless force. Scientists and engineers are tirelessly working to develop lighter, more powerful batteries that will unlock the full potential of electric and hybrid electric flight. The quest for sustainable and efficient aviation is a journey worth taking, and understanding the principles of airplane thrust is fundamental to this endeavor. So the next time you see an airplane gracefully tracing a path across the sky, take a moment to appreciate the incredible science and engineering that makes it all possible. The future of flight is bright, and the journey is just beginning.